Alright, working on another Shovelhead motor here. This is the 67 motor. This is the bike that's in the back room that you've been walking by for about a year and a half now. So we're finally getting around to doing the motor. It's been here for a couple years, probably almost. My backlog. That's a short list. So anyway, we worked on this yesterday. So today's our holiday weekend. So it's 9 o'clock at night now. Yeah, good. So that's what I do on my Thanksgiving. I work. So I blasted all this stuff here. We swapped out the S&S rods for some Harley rods that are made correct. The S&S rods are all ground on sideways. This motor was freshly rebuilt, but it's not done very well. So this is the stuff here that we're going to keep. Most of the other stuff we already got rid of. Redoing everything. So anyway, we're doing a lot of different work on it. This one here had a cracked out. Had a crack through here, so he had this all welded up, and it's been sitting in his house for a year now. So we'll get that rebuffed. So anyway, the cases are in fairly good condition. They've been over tightened a lot here on these holes. I got to spot face all these things off. Got to put new bearings in here. It's got some acid etching in there that we don't like, and everything's been overheated a lot. So I'm not sure why, but a customer bought the bike and there it wasn't running since he's had it. But the pistons are all nice and blue. Down in there. See how they're all nice and burnt and blue? That thing's running hot. This is all the junk stuff here. So the valves are overheated. One of the guides is seized up on it, the exhaust, and all the bearings were blue. All the shafts have a light blue tint to them a little bit, kind of an off-color yellow. So you can tell there's been a lot of heat in the motor. They're not blue, they're off yellow. So anyway, we're going to just replace a bunch of stuff and just put it together correctly. Get a lot of that around here. So this one here, we got a little big gouge in it right there, so GB welded that up, so we're letting that set up right now. The cover right here, it's got a couple spots also. This is what they look like, generator side cover. Correct for that year anyway. Now when we took this motor apart, it was locked up until I undid the cam cover. Once I loosened up all the holes, then the motor would turn over. That's one of the reasons we knew there was something wrong with it. Not sure exactly what was doing that yet, but something was. We'll figure it out down the road. This has all been welded up in here and redone by somebody else, not me. So this is all, you can see where it's been well welded. This has all been welded through here. And these here should have holes like this up under here, and they're all welded up solid. So at least up to about here it's been welded. I don't see welds on the other side, right over here. This all looks original. This is all torn up under here. Something's got into it. This is a big piece of turd cast in here that needs to be ground away. You can see how it's been hit against and ground on lightly, so I got to grind that out. Bad castings. There's a little crap everywhere. So I'm going to strip that hole right here. But your typical motor, it's got issues. Once every hole's been over tightened and no washers, just like this one is. They had acorn nuts a lot of this stuff, which is a lot flatter of a nut, or have more of a curved base to it, so it digs in more. So you can work on that. Flywheels are good, washers worn out, so you can replace that. Like I said, I found a good set of stock rods. The stock oil pump right here looks good. Didn't have the correct hardware on it, but we're going to put the correct hardware on it. The lifter blocks are aftermarket, because Harley ones are figure 8 shaped right through here, like this. So I'm not sure what these things are off of at one time. But I've never seen an aftermarket set that had the countersunk holes in them, so I think somebody cut those in there. So anyway, they look like they're Harley, but they're not by the finish, but they're not Harley because of that. The other way you can tell is how they got an R, or left, an R and an L on here. Harley doesn't put that stuff on their lifter blocks. They have casting numbers in here. Or look for foundries. That's how Harleys are done. Date code, stuff like that. That's how Harley lifter blocks are done. So these are definitely aftermarket. So we're going to do to make it look correct, we're going to take these lifter blocks here, because we don't have any painted ones. These are late shovel, which is late 70s, early 80s. So these are for Allen screws. We're going to convert this over to countersink, just like they did on this set here. But they sunk it way deep inside the block. I'm not doing that. So here's the correct screw. But there's no reason to bury it inside of a hole like that. I'm going to leave mine up real high like this. So we'll show you in a minute what that looks like. So I'm working on that part. So this one here, I gotta do that. These are some used ones that have been sitting around forever. Some heavy lubricant in there. Real heavy. Okay, I'm not sure what size these are, but these are 10 over, so we're putting 10 overs in it. So we'll be honing these out for 10 over. These are Jim's newer style hydraulic conversion for shovel. We're going to use that. We're going to put an Andrews A cam in it. It had a hydraulic cam in it, stock hydraulic replacement cam. We're putting new pistons in it, obviously, because the old ones are all burnt. All the bolts and stuff are lower quality and boogered up, so we're putting new stuff in it. Okay, so all this stuff looks decent. Here's the new hardware we're going to use. We're using old colony stuff, CAD plated, make it look stock. Okay, these heads have been welded on a lot. The combustion chamber has been all cut out on these things, so this has all been welded up for a spark plug hole. And did a repair on the thread, which doesn't look too bad there. But this is not round anymore; it's actually oval shaped through here. This is sticking out probably an 1/8 of an inch higher than it should be through here, which is going to raise the compression way up. Now the bad part is it's welded all the way down to here, and all the way up to here for sure. And you can see how the weld is overlapping the seat. So that means this seat was in there when they welded all this stuff. So when you weld into a seat, you lose the compressed fit on your seat. So if it's not welded correctly, but with this amount of welding here, you know, almost an inch of oil, that's over an inch of weld area. There's no way those seats are tight. So you'd have to replace these seats to make sure they don't come out. They might stay in, you don't know. The exhaust, one exhaust wasn't too bad, the other one's a little bit loose. Not serious, but a little bit. Got a couple broken fins. This one's broken off here. The other one, a big one's cracked on it. Okay, they had down here. This fin's been hit and it's got a big crack right through there, about 3/4 of the way through it. But it has the same issues with the combustion chamber. So these are the original 67 castings right here. One is 67. A lot of porosity, which really weakens things. Almost looks like it's been welded over here. Might have, who knows, I didn't pull the guide out. It's got some helicoiling been done to it. But, so anyway, what we're going to do is we've got another set of heads we're going to use, which are over here. I was trying to find some 67, 68 castings. The customer didn't care if they changed the year. So these are 77 castings. So this is one I've had for a lot of years that I did a lot of repair work on it. So here's where I did my spark plug repair. Now what I do is I weld it close to the seat, but not to the seat, and then I peen the aluminum into it as it cools, so the seat stays nice and hot. Usually it actually moves the seat in a little bit. So, because as it cools it shrinks, so you beat on it, seals it over. So yeah, I don't loosen up my seats, but you can see I only weld right to here. It's not even, I ground it on the edge of the seat, but I don't weld to it. I beat the aluminum into it. You put a little as heat as you can next to that seat. You don't want to come out, get loose. I've also done the exhaust repair on this one here. So it's nice and tight now in a spigot. And this is hard material, so the bolt hole is actually stronger than a cast aluminum. Looks like I did a fin repair over here on it. So, like I said, a couple of them. So I did a lot of repair work on these things. So, and these are 3/4 reach plugs instead of short ones. These are the correct 66 castings, which are short reach plugs, but I put long reach in them. So, well, these aren't 77, it's 71. That's why I didn't have a long reach plug in it. I thought it had a long, yeah, 66 castings, a giveaway. So this is 71 casting that I've worked on. I've converted it to like a 77 head. Alright, so this one's all pretty good other than that. Good fins and everything. Okay, this is a head I picked up here last year or so. Used one. So this is a really, really nice cherry head stock. We just did a cut on the gasket surface to clean up, had some gouges in it I didn't like. It had a helicoil in here already. I re-helicoiled it, and then I put a deep one in there. You can see how it goes in there, almost 3/4 of an inch. I like nice long helicoils, and I put studs in them. So this exhaust port here is like new for fit. It's dirty and grungy, but it's very, very tight. So that's pretty rare on a Shovelhead. All the fins are really good, no damage. Spark plug hole's really good. It's a 3/4 plug, so it matches this head over here. But you can see how this is a 66 casting here, and this one here is not. This one has an 07. Which happens to be the year it was made, I think. Nope, 76 over here. So this is 76 casting. They went to the long reach plug in 75, and that's when they changed the number from here to other numbers. I'm not sure what that code means. It might be the month it was cast in, who knows. Something. Some are marked, some aren't. But anyway, this is a really good head, so we're going to use this. They didn't have any studs in it except for this one, so we robbed this off the other heads. So these are all in here now. So I got to take this and blast this, make it nice and clean looking. This one here was blasted years ago before all the welding was done. So that'll be tonight's project. Go ahead and blast all this. So this was surfaced a long time ago too. So the only real defect I see right here is a little crap right here. So the O-ring will seal it here, so it doesn't really matter, but it's, you know, cosmetically it doesn't look that good. So anyway, those are ready for rebuild once I get them cleaned up. And like I said, the rest of the stuff will be rebuilding the crank and balancing it, replacing the thrust washer. So, this one here is not too bad. This one here is cut into the flywheel pretty heavy. So we'll be dealing with that. So right now what I'm working on is lifter blocks. Right over here. Here's our screw. So this one here I just got done doing. Now I didn't have a big, small enough cutter, so I notched this here a little bit to try to make room. It didn't work. And I finally found the correct cutter. It's an 82-degree cutter. It has to be a 1/2 inch diameter. It can't be a 5/8. I had a 5/8 I was using. Oh, I just put that in there, so it's in the way now. So anyway, that goes down like that, and it goes down the hole and countersinks it. Then you put your screw in there, and it drops right in. It sits nice and tight, doesn't wobble around, just like you want it to be. And I'm sitting up nice and proud, so you can see the whole head of the screw, and it's not buried inside of a hole to collect water and rust and cause issues. So that's how they should be. They shouldn't be buried inside like that. They got plenty of thread, so that extra 1/16 of an inch that you didn't go in is no problem. You got 2 diameters plus there, which is over 1/2 inch of thread hanging out, so that's plenty. So that's not an issue. After I get these done, I'll go ahead and blast all this wrinkle paint off, and we'll paint them, probably paint them silver. Everything else is silver on the bike. Silver is what they used back in the old days. Alright, so I'm going to go ahead and swap this around and do another hole. And we got 7 more to go. I forgot my tripod though. Oh, we got 20 minutes after already. Think I'll be out of here by tomorrow? Maybe. We'll see. Lock that thing down. What the hell? I'm trying to get my camera to work here. There we go. Something got a little carried away on the crank handle there. Yeah, gonna make it so you can move it. Move it like that. Some people want to see me. I don't know why. I didn't look it up. I do read comments and re-comment back, so if you make a dumbass comment, you'll probably get a smart-ass remark. If you ask a question, I'll probably answer it. Alright, so we're going to do this. Okay. So I'm just crimping in it. Yeah. The vise here against the flat right here is what I'm going against. It's not much area, so I use the clamp to hold it down to make sure it stays down. Don't want it to move on you. Okay, get this out of the way. We use a drill bit for centering the hole up. Let's go ahead and rotate the block around. This doesn't have to be right in the same spot, but it doesn't hurt to be close. My problem is too close this way now. And I'm not sure I'm going to make this clamp work like this. We got to get away from that clamp. Let me go over here. Go to the other side. There, now I can clamp it, and I'm not on my way my drill bit over here. Put a little pressure on the top, and we just tighten up there, and tighten it up there. There we go. I think it's just pretty centered. Then we gotta do some more centering. Get over here, you can see better. Blow it up a little bit. Okay, so now what we gotta do is find our dead center. So by moving the drill up and down in the hole, you can hear it hit on it. Turn 180, do it again. You want to hit equally on both sides. Drills rarely chunk up in a chuck square. Come over and check this side. See how the drill moves, walks way over. Move it over a little bit. Move it over some more. Barely hitting. Turn it over here, see what's hitting. It's kicking this way a little bit right there. Check this one again, a little bit heavier. Move it over into the couple thou. Alright, zero that all out. Okay. So I'm going to put our countersink in there. Remember, it's 82 degree angle, 1/2 inch diameter. That's the key to 1/2 inch diameter. It's got to be small. Okay, I need to come up with a set depth. So if I put a nut on top of here, I can come up with a set depth to use. Or a couple washers or something. Whatever I got laying around to use. I'm gonna go find me a nut real quick. Let's go find a nut. Trying to make a repetitive depth would be nice. Oh, let's see. We got some 5/16 nuts right here. Right in this box of crap down here that we're not using much of out of here. There you go, 5/16 nut. There you go. There, now I can just push it until I hit the chuck, and that's a good dimension. It's small, so it shouldn't hit on anything. Alright, that should do the trick. Just gotta come up with a way of doing stuff that repeats. Alright. Now you shove it all up some touches, tighten it up, and that should clear here, hopefully. It's going to be close. Like that little washer in there. I'll find me a little washer here to use real quick. Let's see here. Get a little washer right here off this bolt. A little AN style washer, a thin one. Small diameter's the key. Okay, that gives me just a little bit more. Actually, I want that on the top. It's bigger. Okay, we'll put that like that. So, give me just a little bit more clearance. trick. Okay, so now we just go down a certain amount. Set our depth stop up here on the top. This is our depth stop right here. So let's go down until that touches, and I got the crank wheel down here. Way down here. Down here I can crank the table up a little bit. So we'll figure out where we want to be at. Okay. We're doing 100 RPM, so it's nice and slow. Pretty good. Voila. There you go. Sitting pretty. I like it. Go ahead and zero this out so I know where we're at. I might go up and down, you know. We might fine tune that a little bit, but we're pretty close. So now you can see how it's right in here like this. We got a little bit cut up on the top. Drops right in the hole. Sits nice and proud like it should. Not buried in the hole. We got plenty of thread below it. So that's how I like it. Looks really good. Like that's a good finish, good quality hole. So that's what we want to do. I got a setup now that's going to be fairly repetitive. I'm just going to loosen this up, rotate the block, have the drill in there, have my drill bit right in here to center it with. That gets pretty close, and we just do our fine tuning, and then we zero it out so we know where we're at. And our depth is already preset because we put the nut in the washer there, so it goes back in the same spot each time. Okay, loosen that up, pull that out. Just rotate this. I got this little piece of aluminum there so I don't nick up the block. It'll dissipate the pressure away, whatever I'm hitting on. Okay, we'll just put that in a hole like that. Figure where we're going to hit over here. Looks like we're hitting a little bit higher up this time. Move this up another position. Light pressure on that. Tighten up the vise there. And put some more pressure on that. Okay, now we check our hole location. A little heavy off that way. Looks really good. So I moved to 7 9 off from the last location. Which ain't much. Amazing how much you can see a couple thou movement when you move these drills side to side. You can really tell. Okay, tighten that up. Now we should be able to just put this right down there in the same spot and run it on in. So we got our table set down here. We're zeroed out. Now we don't know if there's height difference in here, so what we can do is we can take this and move it up 10. Put that on 90. So we're dropped at 10 thou on the table, so now we can pull it down. And if it's too high, I mean if it doesn't cut deep enough, we'll just give a little extra. Because the blocks are just cast, they're not consistently on one size. So we haven't changed the depth stop here at all. Check your hole and make sure it looks pretty even. Appears to be pretty even all the way around there, it looks like. I'm just cranking this around the hand here. So we're just using light pressure in my hand. We go down until we get to the stop right here. I'm just using my thumb right here to do it. So we're against that stop right there now. Okay, this one appeared to be a little bit taller on this side, so it's sitting up a little proud. Alright, I'm good with that. So you can see how it's countersunk in there a little bit deeper than it needed to be. So it's a good thing we backed that off 10. Okay, so that's 3 out of 4 done on this block. So now I'm going to go and get that back one over there. So that'll be another one over there to do. So we're just going to rotate the block around, just like we just did. So once you got it set up going, it goes pretty easily and quickly. Go. Okay. Center it. Good that way. Pretty close. Alright, I'm with the tooth towel. That's pretty close. Tooth towel only one direction. Okay, same thing, you put it all in, shove it all the way up, tighten it down. We're ready for another shot. Now this one looks a little thinner on this one than the other one. It's got a cross section, looks thinner on this one than this one. But we'll find out. It could be an illusion. We'll find out. Fairly even there. You can see the taper in the part. You can see it's cut more here than it is over here by just a little bit. Bottomed out. So you're cutting heavy up in here, not barely getting over here. Put a screw in there, look at it. See, we're up a little bit higher than we should be up there right now. So we'll go ahead and give it that extra 10 that we give over here. 10 more thou. Makes it look more even now. It's not sticking up quite so high now. I'm gonna blow it up, you can see better. This looks like it fits here. It's a little bit high on this side, and obviously it's getting sunk in over here on this side pretty good, but it's nice and true and straight. That's what you want. Centers right up. So now one advantage of these old tapered screws, You don't need alignment blocks because every screw is centering, see? The old way of doing stuff worked better in new ways. But Harley just made stuff cheaper, so didn't make it better. A lot of stuff was not an improvement. Alright, so that's done. See this one here, they always want you to center them up because they can sit here, here, here. With a tapered block, it self-centers. You don't do any of that crappy stuff. Makes it a lot easier. See, this guy just lays on there, we're tightening on it. See how it's getting marks on this instead of on the block. See, block has only just indent mark from aluminum. It's not damaged in any way. Doesn't hurt it any. Okay, so that's one down. So I'm going to do our other one. This one's going to hit way over here, it looks like. Quite where I want it to hit on, but well, that's where it's going to hit this time. That's bad. See, it's lifting it because it's not hitting evenly. Just trying to avoid that. Let's see here. We need to put something under here to equalize the load. Without doing damage to the block, it's going to be rough. On this one, we're going to have to leave that off. We'll just hold it with a vise. Okay, let's see where our center is at. Ooh, jeez, way off. All right. Back off that 10 we did. It's a different block, so we're not quite sure where we're going to be at. So go ahead and do this one here. Nice. Perfect. That was at 10 under. So good. I think we're hitting on the bottom of the jaws under there. These are probably sticking out, hitting the bottom of the vise. Something's moving me around. I don't know what that is. Something's not even. Oh, it's hitting right on this. Whoop. We're tall enough, but we're hitting on this corner right here, which is going to be a problem. So I got to make sure I don't get in that area. Stay. We're good right there. We're hitting on this side on something. It's cocking up on us. It's a hidden one. It's hitting on this right here. It's thick edge. So this needs to be cut away a little bit. Oop, that other one. It's pinching me against this, so I'm gonna go ahead and do a little work. I'm gonna file it down. This is just extra material, so doesn't really, it's not really needed for anything. Doesn't hurt anything. One benefit of doing this is it goes in the motor easier too. Doesn't hit. Go. See, this one was an undercut like that. That's why I didn't have a problem with this one. This is the rear one, I bet. Nope, this is the front one. I don't know why the front one's undercut so much. It's just a low location where the block is, I guess. Well, either way, now we eliminated some of the clearance issues. Hopefully now it'll work. See, which one was I on? I was on this one over here. It's not tilting up like it was now. Ooh, we're out of view. It was picking it up when we did this. Now it's not. Good. So we put a clamp over here now. It feels flat on the back side. Okay, center this one up. Too much, not moving at all on that side. It's kicking on this side. Let me zero this out so I can find my spot. Give it a couple thousandths. Probably work. That side was good. Alright, I think we're good. We don't hit anything. That washer is going to be really close. Might hit the washer. We'll see. If it does, we'll pull the washer out. Take a look right in here when you come down. See how the washer is going to be real close right there. And we'll see what happens here. Hitting and ain't by much. Still looks good. I'm just about there anyway. Okay, that's it. See, not really. You see, we barely see a rub mark now, right there. We just touched it. Right on it. Okay, that looks like it's pretty good. Looks like a good depth. Looks like it fits pretty nice. I like that. I can live with it. Okay, I'm going to swap it over to the next one now. See, every one of these are just slightly different how you do them because you run across little interference issues. Just got to figure out what to do to make it work. Pull that around. I think we're going to have another problem over here. Nope. Pull in tight. Block right there. Oh, what am I doing? Dumbass. Wrong thing. Getting heavy on that one. Getting heavy on that one. Maybe slightly further, but not by much. 2.3 thou different. Definitely too far. Oh. Damn it. 1.4 thousandths change. A little bit more than that. Just 2. That looks good. There's 0.3 of a thou difference. The other one knows 0.3 of a thousandth. You can see it. Oh, too much. That was an 0.8 change on that one. That looks good. Yep. Very small numbers, but you can tell. Wrong direction. That way. Okay, this one's going to be close also. Ooh. Ooh, that is going to be real close. I think it's going to hit. One might hit on that one. So we're going to hit right here in this corner. On the side of the chuck up there, see? Be real close. We're probably going to hit on it. We'll see. And this one's going to have to go deeper, I bet, too, because it's much lower. Good so far. See it. Looks like we didn't hit. Okay, yeah, that looks good. Gets a good height. Looks pretty even to me. Yeah, I could probably go 5 thou more, but I think we're good. I'm good with that. All right, that was really tight. See, this one's way tall, that's why it's a problem. Next corner is tight, but it's low, so we're not going to have the height issue. And the 1/2 inch diameter cutter eliminates the side issue where it was hitting. Okay, we got a problem right here. Okay, we're on top of a spot. So the drill is overlapping. I can't get to clear the drill. Don't have room. It's not going to let me work in that spot. I have to move it. interference issue. Oh. This isn't working very good either. Nothing's working on this one. Alright, we're losing that. Just have to go with holding it with a vise. What happened here? Oh. Dumbass. Okay, I can't go all the way through this because I'm on top of the chuck because I couldn't turn the lifter block because I was hitting on the spots where they're sticking out. Wouldn't work. So we can't check the screw height, we just have to eyeball it. Have to take it out, check it. If I don't like it, we'll put it back in and redo it. This hole is really different looking. It's way too far over, that's why. The more I move it, the better it looks. Too far that way. Enough that way. Alright. Let's fire a towel off on that thing. There. Definitely bound up. Okay, so now this one here, we just have to play it by ear. Hopefully we shouldn't hit on anything. Try it, do another 5. Looks good. Oh, it did fit in a hole. I didn't think it was going to fit in there. Okay. Looks good. Probably gave 5 thou too much, I'm guessing. Yeah, it's a little bit deeper than the other ones, so. Yeah, actually went a little bit too deep. See how it's not quite. If it's up just 5 thou higher, it look better. I guessed and overcut it. Oh well, I can live with it. Alright, so that looks good. So there you go, that's how they're supposed to look now. So now when you put these in the motor, they go like that in the motor. We got all the correct screws in there. They'll look correct. Like that. And that's how you do that. So you make your parts work. Okay, so I could go blast these. I'll get these cleaned up and then I'll come back. We'll hone them tomorrow. And then final finished. Alright, that's it for tonight on this one. Alright, we're back at the home shop working. What time is it now? Almost 11 o'clock now. Homework is being done right now. So it's 68, it's down 2 degrees already. So I'm blasting these heads I worked on down at work earlier. So this is the one that was all welded on. So that's what the exhaust repair looks like after it's all done. He's all blasted. It's pretty good. We did the spark plug repair. All looks stock. Nobody notices really anything's been done. A couple pin repairs over here. Don't even see them. So that's how it's supposed to look when you do a head repair. So, over here we're doing the other ones. This is what it looks like partially done. See what the bead blasting does. This is beads around here. Those are little actual actual balls, silicon balls. So the sand's real rough, of course. These are pretty fine to break up. So you see how it doesn't really hurt the surface when you blast it. Just kind of smooths it out. Cleans the carbon out of the motor pretty good. Makes the head look a lot better, obviously, than what this one does. Before and after, big difference. So, these are lifter blocks that I just got done working on. So this is the before. This looks like after you clean it. So now this is ready for paint. This one, not yet. These are the cylinders I welded the other day. Another video. So these are waiting to be blasted. So I did 3 sets the other night. Had a few hours of work and a couple more hours of blasting time at least. The blaster sucks up way more air than I think with my air compressor here. They're up to 120 pounds now. How you cool the air down, gets the water out of the system too, it's pretty good. Alright, so this stuff is all done here. So this is some other stuff I blasted. That's before, that's after. You can see how corroded it makes the steel. The aluminum doesn't hurt too bad, but not very good on the steel. The aluminum gets pretty eaten up too, but that's more junk. There's the other half of the case. Other junk cases, just something to screw with. One of my junk motors. Got a few of them floating around here. A little stack of cylinders over here. There's another old racing motor. This is a 40 WLDR here. KHRs over here. Mixture of racing parts. That's my 46 WR motor there. You have to Google to see what all those things are. But, oh well. Alright, let me get back to blasting. Get up to 130 pounds. Shuts off at 175, but I'll get half the head done with this pressure. It's gone up another degree already. 69.5. It's going up all night. Alright, that's it for now. Alright, we sucked it down. So we're down to about 70 pounds over there. Didn't get to that yet. Well, I got the combustion chamber all cleaned up. All good. I got most of the ball holes cleaned out. A little bit of residue in there still. Dashboard is clean. Top of the head's all clean. So now I gotta do all the pins on it. different ways you can blast stuff, whatever works for you. Can't see much through that window, so pretty much have to blast in pattern. I always start on the combustion chamber, do the intake first, exhaust, get the 2 ports. Then I flip it over and get this side. You have to get it from all 4 angles, this way, this way, this way, and then this way. That way you get the studs from all the different spots that you might miss. Clean down inside of there. Important to get all that crap out of there, that's how it cools. Anyway, that's how you do that. So, I think I missed a spot right there. I'm going to carve it up under there. Yep, missed a spot. I'll come up and get that. Well, that's how you do it. So, we'll be back in a few more minutes. Alright, here's the head all cleaned up. All the way down in the boot. All the way down. Make sure you clean all the way to the bottom so it cools correctly. And that's what it all looks like. Nice and clean. Matches the other one. Got the other lip block all cleaned up too. So these are all clean. These are ready for some honing. We gotta paint them. Well, that's it for tonight. No more shop work. I'll get on the house and do computer work. And upload videos until the sun comes up. There you go. Down to 80 pounds pressure now. Yeah, it's almost 72 in here now. It's starting to be comfortable. So there we go. There's a Unihone, it's my blaster. You find these used, they work pretty good. Doesn't get too dusty inside. A little bit, not too bad. You always get a little bit of dust in the inside, but not too awful bad. It's mainly all back here. All the old junk. So, secret stash of crap. Alright, well that's it for tonight. Time to get out of here. We'll work on these heads and stuff tomorrow.